Hello everyone. In this video we'll study our next topic of the same chapter, which is equations reducible to a pair of linear equation in two variable. Okay, means in this section or in this topic we will solve such equations which are not linear, okay, by making it linear equation. Okay, see, we have studied in the very beginning of the chapter that for a linear equation, okay, for a linear equation power of the variable should be 1, like 2x plus 3y is equals to 4. Here in this equation power of x is 1 and power of y is also 1. So these are linear equation. Okay, suppose we are given with such equations in which power of x and y or power of any variable is not 1, okay, it is negative or something else. So we have to first make it linear equation, then we will solve it by any of the method. Okay, see, for example, see example number 17. Equation is 2 upon x plus y upon 3 is equals to 13, and second equation is 5 upon x minus 4 upon y is equals to minus 2. Okay, see, this can be written as 2 into 1 upon x, and this can be written as 3 into 1 upon y. See, 1 upon y, we have studied laws of exponent. Okay, see, 1 upon x can be written as x to the power minus 1. See, x is in denominator of the fraction. No, if we turn it up to be a numerator of the fraction, then its power will be minus 1, and 1 upon y can be written as y to the power minus 1. Okay, see, then after removing this from denominator, their power will become minus 1. Okay, x to the power minus 1 and y to the power minus 1. So the equation, this equation is not a linear equation. Okay, this is the law of exponent. 1 upon x is equals to 1 upon a can be written as a to the power minus 1. Here power of a is in denominator, so power of a is minus, so power of a is 1. So when we will make it, when we'll write it as a numerator, then it will become a to the power minus 1. Okay, so this type of equations we have to solve in this section, okay, or in this video. Now to understand this, how to reduce, let us take one question of exercise 3.6 and its fifth bit. Okay, see, equations are 7x minus 2y upon xy is equals to minus 5, and second equation is 8x plus 7y upon xy is equals to 15. Now here you will see denominator is xy and here also xy. Okay, means x multiply y. Here power of the variables is 2. Okay, so first of all we'll simplify the equation. Okay, simplifying this given equation, see, 7 minus 2y upon xy means xy is LCM of both the terms, both the fractions. So after separating it, it will be 7x upon xy minus 2y upon xy is equals to 5. Okay, now x will be cancelled out here, y and y will be cancelled out in this fraction. So we will get 7 upon y minus 2 upon x is equals to 5. Now see, for the second equation, it is 8x plus 7y upon xy is equals to 15. No, see, xy is what? LCM, okay, of both the terms or fractions. So after separating, we'll get 8x upon xy plus 7y upon xy is equals to 15. Again x cancelled, and in this fraction y cancelled, so we'll get 8 upon y plus 7 upon x is equals to 15. So here this is the first equation and this is the second equation we have to solve. Okay, now here the variables are not linear. Okay, so we have to reduce it into linear equation. Okay, so putting x is equals to u, another variable, we will assume, suppose that 1 upon x is u and 1 upon y is v. So after substituting these values in first and second equation, we'll get 7v minus 2u is equals to 5, and this will be third equation. Name it as third equation because this is in the terms of u and v. Okay, now from second equation, if 1 upon y is v, so 1 upon y is v and 1 upon x is u, then 8v plus 7 u is equals to 15 is our next equation, or you can name it as fourth equation. Okay, now see, we have to solve equation number third and fourth by any of the method. Okay, by any of the method we will solve these two equations to get value of u and v. Okay, in standard form, let us solve this equation by cross multiplication method. So to solve it by cross multiplication method, we need to write in standard form. Okay, see, using cross multiplication method, in standard form equations are this. So using cross multiplication method, variables are u and v. So u upon denominator, u is equals to u upon denominator is equals to 1 upon denominator of these variables and constants. So for variable of u, v, what will take these two coefficients and these constant numbers. Okay, so minus 2, 7, minus 5, 15, minus 5 and 15. For u, this will be carried here. So for variable u, minus 5 and minus 15, minus 5 and minus 15, and coefficients of v. Okay, 7, 8. Now for constant term, leaving this 7, 8. Okay, variables of first coefficients of first variable, and then minus 2, 7 coefficients of second variable. Okay, now cross multiply it. After cross multiplying it, we'll get minus 2 into minus 15, 30, minus 7 into minus 5, it is minus 35. Now for u, minus 5 into 8 is minus 40, minus 15 into 7, it is minus 105. Okay, now for this term or this fraction, denominator, see, 7 into 7 is 49, minus 8 into minus 2 is minus 16. Okay, now after simplifying the denominators, we'll get u upon 65. Here 30 plus, see, minus will become plus, so 65. Minus 40 and minus will become plus 105, so plus 65. And 49 and here minus will become plus, so 65. Okay, so we'll get u upon 65 is equals to v upon 65 is equals to u upon 65 is equals to 1 upon 65. After comparing any two term, v upon 65 is equals to 1 upon 65 will give us v is equals to 1, and u upon 65 is equals to 1 upon 65 will give us u is equals to 1. Now we got value of v and u 1, and v was equals to 1 upon x. So 1 is equals to 1 upon x, so x is equals to 1. Also u we have assumed as u equals to 1 upon y. So value of u is 1, so 1 upon y, 1 is equals to 1 upon y, so y is equals to 1. In this way we can reduce the equations and we can get the value of actual variable. Okay, now see this 8th bit of the same equation, same question. It is question number 1 of exercise 3.6. It is 1 upon 3x plus y plus 1 upon 3x minus y is equals to 3 upon 4. And second equation is 1 upon 2 into 3x plus y minus 1 upon 2 into 3x minus y is equals to minus 1 upon 8. Now here see, in first equation and second equation, see, we have 1 upon 3x plus y, and here also we can write it as 1 upon 2 into 1 upon 3x plus y. So 1 upon 3x plus y we can substitute as some other value or other variable. Okay, and 1 upon 3x minus y in first equation also, and in second equation also we can write it as some other variable or other value. Okay, so on putting 1 upon 3x plus y as p and 1 upon 3x minus y as q, we will get this equation. 1 upon 3x plus y is p, so p plus q is equals to 3 upon 4. After transposing this 4 to our LHS, we'll get 4p, because 4 will be multiplied by these two terms. So 4p plus 4q is equals to 3 is the first equation. Now for second equation, was 1 upon 2 into 3x plus y. So 1 upon 3x plus y was p, so here it will be p upon 2, and here 1 upon 3x minus y is q, no? So 1 upon 3x minus y, you will put q, in place of that you will put q. Okay, so p upon 2 minus 2 upon q upon 2 is equals to minus 1 upon 8. Now if we And see, LCM of we can take LCM of these two fractions because denominator is same. So p minus q upon 2 is equals to minus 1 upon 8. Further, p minus q upon 2 was there, no? So 2 has been transposed to RHS. So minus 1 into 2 upon 8. It is divisible by 2. So minus 1 upon 4 we will get here. So p minus q is equals to minus 1 upon 4. Now p after transposing to LHS will get minus 4 4p minus 4q equals to minus 1 is the second equation. Okay, now we have two equations. First equation was 4p plus 4q is equals to 3, and second equation is 4p minus 4q is equals to minus 1. Okay, now see, in both the equation coefficients of p is 4 4 and coefficient of q is also 4 4, and coefficient of q, one is negative and one is positive, so we can eliminate any of the variable p or q here. So let us eliminate q here, because if we add these two equations, q 4 plus 4q and minus 4q will be cancelled out. Okay, so after adding these two equations we'll get 8p plus 0 is equals to 2. 3 minus 1 is 2. Okay, so p is equals to 2 upon 8. So p is equals to 1 upon 4. Here we got p is equals to 1 upon 4. Okay, now putting p is equals to 1 upon 4 in first equation. Okay, first equation is this. First equation is this. Okay, so putting p is equals to 1 by 4 in first equation, we will get value of q. So q is equals to 1 upon 2. P is 1 upon 4 and q is 1 upon 2. Now what we have assumed that 1 upon 3x plus y is equals to p, which is 1 upon 4. So from here we'll get 1 upon 3x plus y is equals to 1 upon 4. Okay, after taking reciprocal on both the sides, we'll get 3x plus y is equals to 4, which will be our third equation to get the value of x and y. And 1 upon 3x minus y is equals to q we have assumed in the beginning of the question. So we'll get 1 upon 3x minus y is equals to 1 upon q. Again, taking reciprocal both the sides, we'll get 3x minus y is equals to 2. This is our fourth equation. Now to get the values of x and y, we will solve third and fourth equation by any of the method. Again, we will see here plus y and here minus y. So if we add these two equations, variable y will be eliminated and you will get 6x is equals to 6. So value of x is 1, and putting x equals to 1 in third equation or fourth equation, any of the equation you put, you will get y is equals to 1. Okay, so this was the solution of equations which are not linear. Okay, equations which are not linear, and you have to make it linear first, then you have to solve it by any method. How you will make it linear? By substituting the given variables in terms of some other variable. Okay, thank you.